In 1911, Ernest Rutherford proposed the Rutherford atomic model, which is also known as the nuclear or planetary model. The model was based off a 1909 experiment performed by undergraduate Ernest Marsden and supervised by Rutherford and Hans Geiger. This experiment was known as the gold foil experiment. In this experiment, alpha particles, or helium nuclei stripped of their electrons, were aimed from a radioactive source at a sheet of gold foil.
A movable screen covered with fluorescent zinc sulfide was used to detect the alpha particles. When the alpha particles hit the screen, they produced bursts of light or scintillation, which could be seen through a viewing microscope on the back of the screen.
This is a diagram of the experiment. In the lower right-hand corner, you can see another smaller diagram of what happened when the alpha particles passed through or were reflected through the gold foil.
What they found was completely unexpected. Rutherford and his colleagues had expected to find the alpha particles passing through the gold foil with little or no deflection, as they had based their hypothesis off J.J. Thomson's plum pudding model, which spread the mass and charge equally throughout the atom. However, they found although most of the particles passed straight through or were deflected at small angles, some of them deflected at large angles and others were reflected back to the source. Later, Rutherford famously said, "It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you."
The implications of these results were that the alpha particles were interacting with a dense and positively charged particle in the atom, or the nucleus. This is the planetary model of the atom. In the planetary model, you can see there is a positively charged nucleus and the negatively charged electrons. As this was based wholly on classical mechanics, there are no electron orbitals, and also, as the neutron had not been discovered yet, there is no neutrons.
The model was a huge step forward from previous models, which had regarded the atom as a solid piece of matter, contrary to the nuclear model, which was mostly empty space.
And although Rutherford's model was based on classical physics and therefore inherently flawed, it provided the basis for future models of the atom, such as the Bohr model, which was based on Rutherford's model.
Sillä ei tätä poikoo kai saittaa, sillä kato siellä, josta laitaa.